Okay, so we'll have a look at this proof by induction inequalities type. So we are going to start off by, let's write down the rule that we've been given. So n squared is greater than or equal to 4n plus 3, and it tells us that this is valid for natural numbers bigger than or equal to 5. And so, let's start by subbing in 5. So sometimes we show that it's true for n equals 1. In this case, it's not true for n equals 1, or it's possibly not true. It's valid for numbers that are bigger than or equal to 5. So let's sub 5 into the left and the right hand side. So we have 5 squared is greater than or equal to 4 by 5 plus 3. 25 is bigger than or equal to 20 plus 3. And this is true. 25 is greater than or equal to 23. So we've shown it's true for n equals 5, the smallest number that works. The next thing we're going to do is we are going to assume true for n equals k. And that just means writing down the formula as it is, except we replace the n's with k's. So we're going to assume it's true for k squared greater than or equal to 4k plus 3. And we'll return to the assumption in a minute. Next thing we're going to do is we want to prove that this is true for n equals k plus 1. So we take our assumption and we replace the k's with the next term. So it's k plus 1 squared on the left hand side, and then it's 4 bracket k plus 1 plus 3. And we can do some tidying up to this. I'll leave the right hand side as it is for now. I might come back to it, or the left hand side as it is for now. I might come back to it in a second if I'm not happy with it, but I'm going to leave it as it is. I'll multiply and tidy up the right hand side though. So it's 4 by k is 4k, 4 by 1 is 4, plus 3. And so what we're trying to prove in this question is that k plus 1 squared will always be greater than or equal to 4k plus 7. Again, with the condition that k or n has to be bigger than or equal to 5. Now, I like to put some color on this. I like to say we're trying to prove that a is bigger than c. This is where we're going with this. We're going to return to the assumption, and I'm going to write the assumption again. So I have k squared is greater than or equal to 4k plus 3. I know this is true, and I want to work with this to turn the left-hand side of this into the left-hand side of what I'm trying to prove. Now, the left-hand side of what I'm trying to prove has a k plus 1 squared, so it's going to be a little bit tricky to turn this k squared into a k plus 1 squared. So what I'm going to do is let me multiply out the left-hand side of this, square the first, square the last, twice the product, and that's what I get. So these are still my a and c, as I call them. I'm trying to prove, in my prove statement, I'm trying to prove the k squared plus 2k plus 1 is greater than or equal to 4k plus 7. I know that k squared is greater than 4k plus 3. That's in my assumption. And so what I'm going to do is I am going to add 2k plus 1 to the left-hand side of the assumption. So I now have k squared plus 2k plus 1. If I add 2k plus 1 to the left-hand side of the assumption, and I want to have a statement that's still true, I have to add it to the right-hand side. So I'm going to add a 2k plus 1 to the right-hand side. So I've taken the assumption which is true, and I've added the same things to both sides. So I still have a true statement. So what I have now is, I'm going to tidy this up. I have k squared plus 2k plus 1 is greater than or equal to 4k plus 2k is 6k, 3 plus 1 is 4. Now, again, going back to my colors, this was the assumption, and the left-hand side of the assumption now looks like the left-hand side of what I'm trying to prove. K squared plus 2k plus 1 is greater than or equal to 4k plus 7. The right-hand side I'm going to call b. Now, the inequality types, the key to finishing them is, we're trying to prove that a is bigger than c. We can see now that a is bigger than b. So if I can prove that b is bigger than c, well then clearly a will be bigger than c. So b is 6k plus 4. And I want to prove that that's greater than or equal to c, which I'm calling 4k plus 7. And let me run through that again. With these inequality types, what we're trying to do is we want to show that a is bigger than c. we can see that A is bigger than B from the assumption. And if we can show that B is bigger than C, well then clearly A is bigger than C. So working with this now, I'm going to collect the k terms on the left. So 6k minus 4k is 2k. Greater than or equal to 7 minus 4 is 3. And then we can divide both sides by 2 to get k is greater than or equal to 3 over 2, which is 1.5. Now what that means is that when k is a number that's bigger than or equal to 1.5, B will be bigger than C, and if B is bigger than C, then A is bigger than C. Well, k will always be bigger than 1.5 because the condition in the question is that it's bigger than or equal to 5. So this is true. I like at the end to write down that k squared plus 2k plus 1, that's the A, is greater than or equal to 6k plus 4, that's the B, which in turn is greater than or equal to 4k plus 7. So the proposition is true for n equals 5. If the proposition is true for n equals k, then the proposition is true for n equals k plus 1, and the proposition is true for all natural numbers greater than or equal to 5. So you need to write out that statement that I've just said to get the full marks for the question. But that's the basics of those inequality types, that you're trying to prove that A is bigger than C. We can prove that A is bigger than B, and if we can somehow show that B is bigger than C, well then A will be bigger than C.